In this lesson, we'll be learning about similar figures. And when we have similar figures, we'll be able to use proportions to solve for different side lengths. But let's first learn a little bit about similar figures. For figures to be similar, the figures must meet three requirements. The corresponding angles must be equivalent. And the corresponding sides must be proportionate. The figures must be the same shape, but not necessarily the same size. And the symbol to show figures are similar is the equal sign with this little symbol above it. That means that they are proportionate, they have equivalent angles, they're the same shape, but not necessarily the same size. So now let's take a look at this example. It says, use the symbols for similar figures to show triangle ABC is similar to triangle DEF. And so let's first start by looking at the corresponding sides. We name sides by using two letters and drawing a line above it. So this side here, side AC, is proportionate or similar to side FD. And I know that because the triangle is facing the same direction. They both have this box in the corner. And I'm trying to figure out, or I can try to figure out, what did I multiply the sides in the original shape by in order to get the new sides. And I think most of you can see that it's just half. So I multiplied by 1/2, or the decimal 0.5. So now let's look for another pair of corresponding sides. Here, side AB is similar to side DE. And again, I write the two letters, the two endpoints, and then I draw a line above it. My next side, or my last side, side CB. Side CB is similar to side FB. And again, if I look at all the side lengths, all I did was divide by 2. 8 divided by 2 gives me 4. 10 divided by 2 gives me 5. And 6 divided by 2 gives me 3. Now, let's look at the corresponding angles. And remember, corresponding angles are equivalent, or that means they just have the same exact measure. So if I look at my first triangle, the original figure, this symbol here means angle. So angle angle C, we name sides with two letters. This is just one letter because it's an angle. So we're going to say angle C is equal to angle F because they both have the same measure. Now because I'm talking about a different angle, I can draw two arcs here. So angle B is equal to angle E. And again, I name angles based on the corner that it's in, so that letter, and then I can use these two different markings to let me know that those two angles are equivalent. And if I look at my remaining angle here, when I have a box in the corner of a triangle, that implies that it is a right angle, or that it was 90 degrees. So I can say angle A is equivalent to angle D. Now, using this relationship, I can make a proportion and solve for missing side lengths in similar figures. My first step is to make a proportion, placing the X on the top left-hand side. So let's look at our example. I need to figure out what side corresponds with X. It says, what is the measure of the corresponding part? Place this number below X in the proportion. And so the short side here is 18. Now let's look at the rest of our figure. This long side, 16, corresponds with 24. Now that I have my proportion, I just need to cross multiply and divide, and then I can solve for x. Alright, so solving my proportion. 18 times 6 gives us 288. And 24 times x is just 24x. Now I'm left with a one-step equation. I just need to divide to isolate the variable. So once I divide by 24, I get that x equals 12. So that means that the measure in this missing figure, figure 1, x is 12. Now let's take a look at example 2. I still have a right triangle, but notice that the triangles are not facing the same direction. For some of us, we can visually see that if I rotate the figures, I can see how they line up. But for some people like myself who aren't really visual learners, it helps to actually sketch it out. So let's see. I have my big triangle here, triangle FEG, and then I have the small triangle JKL. But if I visualize that I'm, in a way, laying the triangle down, I can see how my sides match up. So my right angle was K. When I rotated the triangle, J is here and L is here. So side JL was 13, side LK was 12, and side JK is 5. Now it's a little easier to set up my proportion. So let's see, I have side FG is X. Let's start with that. And then I need to figure out what side corresponds with X. I can easily see now that I have the triangles set up the same way. I can tell that X corresponds with 12. Then I have a lot of different numbers that I could choose from. Actually, I don't, because in my first triangle, I don't know the measure of side EG. So we need to stick with side EF. So 12.5, the side that corresponds with 12.5 is JK, 5. Now I just need to cross multiply and solve my proportion. When I multiply 12 and 12.5, that gives me 150. And when I multiply x and 5, that's 5x. Now I just need to solve my one-step equation and divide both sides of the equation by 5. That lets me know that the measure of the missing side is 30. So side FG is 30. I encourage you to pause the video and try the remaining examples on your own, then play the video to check your solutions. In example 3, it tells me that the figures are similar, and so I need to solve for x by using a proportion. So let's start with here. I have x, and I need to see which side corresponds with x. Luckily, both of these pictures are facing the same direction, so I can easily tell that 6 is the corresponding length with x. Then, go back to my first picture. I have 1.7 over 4.5. Notice that when I set up my proportion, I'm staying consistent. So x comes from the small picture, and then 6 comes from the large picture. 1.7 comes from the small picture, and 4.5 goes with the large picture. So I have to keep the same figure in the same part of my proportion. So it's like when we labeled our units. So I have small, small, large, large. And I'm making sure I keep the corresponding sides lined up. Now let's solve this proportion. When I multiply 6 times 1.7, I get 10.2. And then x times 4.5 is equal to 4.5x. Now to solve the one-step equation, I just need to divide both sides of the equation by 4.5. And when I divide, I get 2.26 repeating. But we just need to round to the nearest hundred. So we're going to round that to x is approximately 2.27. Now let's try example 4. It tells us the figures are similar and we need to solve for x. And then I'm going to make sure I show my proportion in my work. This triangle, I can tell that they're already facing the same direction, so no need to visually rotate it. So let's start with x. The side in the small triangle that corresponds with x, well, from the large triangle that corresponds with x is 25. So x over 25 equals, and now let's look here. The side that corresponds with 3 is 15. So x over 25 equals 3 over 15. Let's solve the proportion. 25 times 3 gives us 75. 15 times x is just 15x. To solve for x, I just need to divide by 15. And that lets us know that x equals 5. Last problem. The figures are similar, solve for the missing side length. Show your proportion. So we have a lot of different numbers that we can choose from this time. Let's start though with the unknown side. Let's start with TU. So side TU is unknown, and the side that corresponds with side TU is side KL, which is 24. And so in this triangle, I know 45 and 18 go together, and I know that 35 and 14 go together. As long as I use corresponding sides, it doesn't matter which values you choose to use. I'm going to use, I think, 35 and 14. So 35 over 14. Now let's solve the proportion. When I multiply 35 and 24, I get 840. And then when I multiply x times 14, of course, that is just 14x. Now I need to divide both sides by 14. And when I do, that gives me x equals 60. So that means the measure of side TU equals 60 feet. All right, in this lesson, we learned how to solve for missing side lengths and similar figures by using a proportion.